Good afternoon, everybody. Thank you for joining today's webinar. My name is Aamer Mushtaq. I am part of the sales engineering team here at Snowflake. And today the topic is continuous data ingestion and transformation. How can you load data continuously and transform it all within Snowflake? Before I begin with the webinar, I'd just like to highlight a couple of housekeeping items. You should be seeing a media player window. If it hasn't expanded automatically, be sure to expand it so you can see the slides and a demo that I will be doing later on. There is a Q&A window that you can ask the questions in, and we will come to the questions and address them at the end of the webinar. So the agenda for today looks a bit like this. We're going to cover what I see as a why question. Why is it important for importance of robust data pipelines, and what should you be using in Snowflake to build these type of pipelines, and the how. That would be the demo piece at the end of the session today, or towards the end of the session. I will be sharing with you a live customer case study, and then we'll come back and try to address all the questions. So data pipelines is a new capability that was announced a few months ago in Snowflake. And when you look at our product innovations, they can be categorized into 4 different themes that we are really focusing on. Obviously, we're a cloud data warehouse, so we're putting a lot of effort and energy and innovating in that space, and adding new features and functionality on a regular basis. We are committed to making Snowflake global. So today we're available on AWS and Azure, and Google Cloud is in private preview at the moment. And we have recently announced cross-region, cross-cloud data replication as part of our global Snowflake team. This is also allowing our customers to start thinking about data sharing from a whole new perspective, and how they can share data across regions and across clouds in a secure manner and with ease. But today the focus is going to be data pipelines, and I'm going to be talking to you about how to build and deploy continuous data pipelines using all Snowflake capabilities. I think we are all aware of the 3 V's, or in fact the 4 V's at times, which get talked about whenever we are talking about big data. And in today's day and age, we all understand that data is being generated from different types of sources, be it websites, applications, or with the mobile phones. Pictures and documents are being generated at a great scale. And this is also introducing a lot of complexity in data architectures in terms of the variety of data that is being produced. But the freshness of data and the accuracy of data has never been so critical up till today, right? It is absolutely important for the decision making to be accurate, that the data needs to be fresh, it needs to be timely, it needs to be delivered in an easily consumable manner from a data platform. So given that the data volume is being generated at such a huge pace, storage becomes a fundamental piece. Having a storage which is cheap gives the opportunity for analytics and machine learning use cases to be expanded, and it makes sense to retain data beyond normal reporting requirements. So if we think about use cases in every industry, there are use cases around tapping into data in real time. We look at telcos. This is call detail records, for example. They want to get access to what kind of activity subscribers are doing. If we look at logistics businesses or even property management, sensor and IoT data, and tapping into that to analyze has tremendous value for the business, and for retailers to see what consumers are doing on their website, how much time are they spending, what are the areas that they're focusing on. All that information allows them to do more targeted marketing campaigns. So if we think from a business perspective, what does that really mean? Then data needs to be queryable as soon as it arrives in the system. So that means the latency and the efficiency have a direct correlation. If we reduce the latency, the chances are that the efficiency of the business is going to improve as well. Data pipelines, which are the means we deliver data into data platforms, they need to be continuous, they need to be robust. The monitoring and the error handling that needs to happen around pipelines need to be absolutely smooth. And the data itself should be easily queryable. It should be, it should be transformed at scale because the volumes are increasing as well. And the platform that is used, the SQL engine and the data warehouse, needs to be able to scale up when there is a need, right? And the data should also be available for all the users to benefit from. It should be consumable in an easy format such as SQL, and should be available through BI dashboards. And not everybody is going to go and write, Python, Java, or Scala code. We all understand that. So if we look at these dynamics and traditionally how pipelines have been built, in Snowflake, we have introduced two new capabilities. One is the Kafka connector, which allows customers who are using Kafka to load data or ingest data into Snowflake in a continuous manner, as well as Snowpipe auto ingest. That's a new capability which will allow you to load data continuously into staging tables. But once the data lands into staging tables, there are a number of questions that typically gets asked, such as, how do I know what changed in that staging table, right? Where do I keep my business logic and transformation logic? How do I run this on a schedule? How do I make it scale and reliable in the cloud? And how do I ensure that exactly one semantic is being maintained? So because of those questions, Snowflake is introducing two new capabilities, which what we call stream and tasks. And these two capabilities, although independent from each other, but a lot of the times are used together. And that's why perhaps you will see a lot of the times they are mentioned together, allow you to handle and tackle all of those questions, right? And move data upstream into a data lake or a data warehousing environment. So let's just go through these one by one and peel back the covers and have a look at what each of these capabilities deliver, right? So if you're familiar with Snowflake architecture, then you would be aware that in Snowflake you could load data using simple copy commands for bulk data loading, or Snowpipe already has a REST API interface, so that could be called to load data from any blob storages such as S3, Azure Blob, or Google Cloud Storage into Snowflake. However, with Snowpipe Auto Ingest, we are automating that experience. Previously, you had to maintain code and use an orchestrator to execute those jobs, but Snowpipe removes the need to have to do any coding or have an orchestrator. It will automatically load data as it arrives into the blob storages. So how does it really happen? Well, there are three steps that make up that data flow. First of all, you are writing data to your blob storage. This could be S3, like I said, and set up event notifications. In AWS world, that would be SQS notifications, which will be sent out to an object in Snowflake called Pipe. Consider Pipe as it's a serverless object, and it will monitor the queue and the notifications that are coming in and go ahead and load the objects in the file that are being dropped into the blob storage. Okay, so that will allow you to load data continuously as it arrives from blob into Snowflake into staging tables. Now, let's have a look at the Kafka connector. Now, the Kafka connector does something very similar. It allows you to, if you're using Kafka, allows you to load data into Snowflake into the staging tables. However, this is not something, I don't think that's something very new. We have had customers who've been doing this on their own, and they've used their existing Kafka streams to push data into Snowflake. However, there has been a lot of challenges in maintaining that pipeline. Typically, there are questions around how do you handle failures, how do you manage stages, and how do you clean up files? If there are missed notifications, then how do you reconcile that? And what if the actual loading job fails? How do you maintain errors? How do you debug it? So all of that had been at the customer end up till today. With the Kafka connector, what we're doing is we are basically providing a jar file that you can store in the Kafka Connect cluster. This is part of your Kafka installation, I would say. And this Snowflake connector basically will hold information such as your Snowflake account configuration. You will define what topics you would like to select and what would be the destination tables that this will be written to. And what the Kafka connector does underneath the covers is actually uses Snowflake internal stages and Snowpipe as a service and uses REST API commands to orchestrate that entire data ingestion pipeline. So it monitors the systems. If there is any failures along the line, it knows it has checkpoints and it can recover from those failures. It cleans up the files in the internal stages once they are loaded, and it maintains it guarantees that the messages will be written once and will not be repeated. It maintains an error log, so if there are any issues, that those can be easily debugged. So it really simplifies that entire data ingestion experience for our customers. And in my opinion, the connector is really delivering the last mile, which has previously been very hard for customers to do. And the Kafka connector is simplifying that experience for our customers and making the entire configuration and management of it is quite pretty straightforward. So let's now look at streams and tasks. Like I said, they're separate capabilities. However, they're spoken about it together most of the time. So streams is basically change data capture capability, so CDC capability. So a lot of the times when data first arrives in a table, the questions get asked, how do I know what data has changed? Because I don't want to be truncating and reloading tables all the time. So stream provides you that capability. Think of it as a bookmark. So as data arrives, it keeps a track of what are the new rows that have been added to a stream object. And you consume these changes through standard DML commands like inserts, updates, deletes, or merges. And this is what typically happens in a data warehousing environment, right? So think of streams as the transformation bit in the ELT. And as you start to consume these changes, the bookmark moves forward and it starts to maintain what other changes are coming into the streams table. You can create multiple streams on top of a source table, which allows you to have different schedules and different ways of consuming that data. Streams are intended for a short period of time. Typically, we see customers, creating streams and capturing the data changes, perhaps on a minute or an hourly basis, sometimes on a daily basis, but they don't really leave that data stale for too long. And when you enable a stream object or create a stream object on top of a source table, what it does is it actually extends this retention period to 14 days. That means it will start to automatically capture all the changes in the last 14 days, and you can consume them, and that's the retention period that the stream will follow. Customers who are using Enterprise Edition and above of Snowflake get 90 days of history or retention period. So if you configure your objects for more than 14 days, say perhaps 30 days or 60 days of retention period, then that's what will be applicable in the case of streams. Tasks are a capability to execute logic and perform transformation. So a task typically has a schedule. You can define dependent tasks, so you can build a chain of tasks or a tree of tasks, so to speak, and pretty complex ones in that manner. So tasks can have dependencies between each other. And tasks in conjunction with streams allow you to deliver a continuous data pipeline and move data along to different tables. And again, in tasks, typically we've seen customers put DML statements or stored procedures which have that logic embedded into it. And you can put conditions on when a task will be executed. So, and I will highlight this happening in the source table, and there are no changes being captured by the stream object, then the task will not execute given that if you've defined it on a condition. So that allows us to execute the transformation logic on need basis and not just keep on running it on a predefined schedule. So the common use cases we see for tasks are perhaps shredding, the semi-structured data types which are landing in JSON and XML or Avro, and landing it into a staging table raw, because that's what Snowflake will allow you to do, and then splitting it up into multiple tables upstream, right? Maybe creating aggregates and keeping them refreshed using task capability, or generating report outputs periodically, which will be consumed by the analyst team. Another new use case that has recently surfaced up is using tasks to perform automatic refreshes as part of your business continuity plan. So Snowflake today allows you to have cross-region, cross-cloud replication. So, for example, in Australia, Snowflake is available on AWS and on Azure. So I could have an account on AWS, which is my primary most of the time, but as part of my business continuity plan, I have another Snowflake account on Azure. And if need be, I can quickly switch between the two. But in order for me to make sure that my secondary is keeping up with with all the changes that are happening in the primary, I can schedule a task, and a task will be the one which will contain the logic of refreshing that secondary database on a periodic basis. Perhaps every minute it will get whatever changes that are there in the primary and push it off to the secondary. That's a cool new use case that we're starting to see in the field. Here, I would like to discuss one of our marquee customers, Capital One, one of the largest financial institutes in the U.S. They've been using streams and tasks for quite a few months, and they're in fact one of the early adopters. Capital One have a very complex environment. They have created, they have a large number of complex applications, and they use Snowflake as their analytical platform. And they've created an API layer which all the users hit, and they've actually connected all the systems through that API layer. And their primary use case was that they wanted to automate a lot of the administrative tasks such as creating roles and security, and perhaps maintaining code inside Snowflake. And they wanted to use tasks for that purpose and make it automated and make it, I would say, integrated into their existing enterprise data platform. So they use that to even further automate a lot of user creation, security, monitoring capability that they already had built on top of Snowflake. The other use case is a common one, and that's what we originally intended with these new announcements, is to bring in data that is generated in near real time into Snowflake, and also allow customers to load data through batch. So what Capital One are doing is they're Kafka customers, so they're using Kafka streams and the Kafka connector to load data into staging tables. Similarly, they use the land data into the data lake, and then use Snowpipe to push that data into the staging tables and streams on top to capture all the changes that have happened. They work like as a trigger, and you have the tasks which are running on a schedule and pushing that data to target tables. So that's a typical data pipeline that we have seen customers build with these 4 new capabilities. So now we're getting to a point where I'm actually going to show you how these 4 or these capabilities can be put together to build a pipeline. The demo today is going to do a number of steps. So I would just like to probably take you through those and then go and execute them. The step number 1 we're going to do as part of this demo is to generate, in fact, output files from a source table that I already have sitting inside Snowflake. So I have this table is a structured table, so I'm actually going to change that structured data into a semi-structured in the JSON format, and I'm going to spit it out into an S3 bucket. Then I'm going to set up my Snowpipe auto ingest job, which is going to have that event-based notification that I spoke about earlier on. So as soon as the files start to land into the S3 bucket, it is going to start to load them into a destination table. I will set up streams to capture the deltas, and then I will set up a number of tasks to work as an orchestration within Snowflake and start to move that data upstream to multiple tables. And then finally, I'm going to also visualize this data change through Tableau and show you how the data refresh is happening in the background and ensure that Tableau is able to represent that. And in the task, you will also see me create maybe dependent tasks, and I will create a tree-like structure where the child tasks only get executed when the parent task has done its job. So the flow of the demo looks a bit like this, where source table, I have a store procedure which is going to actually generate files into my S3 bucket. That's step number one. Then Snowpipe auto ingest is going to load that data into a staging table, and I'm going to name it trips_raw. Then I'm going to set up 3 streams jobs, and they will be named new trips, new programs, and new stations, and these will be the deltas from the source table, and then we'll capture all the changes. And then at step number 4, I will set up tasks, which will have the transformation logic and start to move data upstream to tables, which will be then visualized through Tableau. So these are the 6 different steps we're going to do as part of the demo. So let's just get into it. This is my Snowflake UI. So if you're familiar with Snowflake and have seen this before, I am logged into my demo account, which is on AP Southeast 2. That's the AWS region in Sydney. I'm logged in as John. I have a role which allows me to access to a bunch of databases on the left. So there are 3 tabs at the top, and I'll take you through these one by one. The first tab is the setup tab. So I'm just going to use my role, create a warehouse, you start to use that warehouse, and actually I'm going to create, and I've already created the schema and a database. And then as a next step, I'm just going to create a stage, and this is pretty standard stuff. Remove all the files, and then 2 procedures, which is a stream data procedure, which is going to unload files into my S3 bucket. And the other stored procedure I have is the actual purge file that is going to go back and delete the files when we have loaded them into Snowflake. So that setup has already been done. Let's move ahead and look at working to start to load data using the pipeline. So I'm just going to set my context. And let's see this stage. My stage is called streaming data, and this is the URL that I'm pointing to. Okay, and it's in AP South 2, and this is the actual notification channel that the pipe will be communicating in. Okay. So if I list the objects in my stage, I don't have anything at the moment. This is I hop over to my S3 console. These are the 3 buckets. This is the bucket that's actually going to receive some files. There's nothing in there at the moment, right? So let's go and create a table. And if you notice, I'm just creating it. It's a raw table which is going to have JSON files. I'm just creating it with one single column. I'm using variant data type, which allows me to load JSON files in a native format without actually requiring any transformation. The next step is I'm going to create the pipes, or actually a pipe with this command, and notice the flag auto ingest equal to true. That means this is automatically going to load files as they arrive in S3. And the pipe will actually run this particular command, which is copy into the table from the stage, right? So that's the integration between pipes and stage. Let's see what kind of configurations I have. Again, I can see that my pipe is now using my notification channel, same notification channel that I have set up on my stage. As a next step, I'm going to set up 3 streams, and these are going to capture changes on my base table, right? Let's start to load some data. So I'm going to call my streaming or data loading stored procedure, and it's going to load data into the S3 bucket. With this command, it's actually just going to load 1 day's data. So if I quickly look at my bucket, I have 64 files in there, and I can quickly read these files, show you that these are real JSON files. And let's have a look at the status of my pipe. It has 64 files, it says. It's running. It has 64 files which are pending, and it's using this notification channel to communicate with the stage. All good so far. Let's quickly see the copy history, which will allow us to see, how many files that have been loaded by Snowpipe so far. So I can see that this particular file, and it gives me the date time stamp. So it's starting to already load some files, as you can see from the window. Now let's take account of the table. I have around about 21 or 22,000 records that have been loaded into my raw table. If I go back and have a look at the status of the file of my pipe, now although it is still running but it's already loaded all the files, so there are no more pending files as per the status. Let's have a quick look at the table itself, and as you can see, I've loaded the data in its raw native format. I haven't changed anything. The next step is to see the streams, and I'm quickly going to have a look at one of my stream tables, and these are the deltas, right? So it tells me that I've got 21,962 records, and this is the delta that the stream table object has captured. When I select the stream table, it has a couple of additional, actually has three additional columns, as you can see. This is the original data column. There's the metadata action column, which has the inserts and actually the action which has been done on the base table. So this is an insert. This is not an update, so this is false, and every single row ID is unique. So that this helps me identify every action that has happened on the source table. As a next step, I'm going to create my 3 tables, which are my destination tables. So I'm going to start to model this data. So I'm loading it raw into one single table. Then I'm going to create a model and split it into 3 different tables. These are going to be called trips, stations, and programs. Let's set up a different compute cluster to run that. And as a final step, I'm going to create tasks. So the first task is going to load data into my trips table from streams called new trips. So those are the deltas, and I'm going to push it into my trips table. The next task is going to do something similar. It's going to use the other stream, which is around new programs that are being loaded, and it's going to load it into the programs table, right? And as you see, this logic starts to, now I'm doing a merge statement as part of this task. My original task the previous one had only an insert statement. So that was the use case around, on one base table, creating 3 different streams, because now I can start to consume this data in a different manner if need be. And that's exactly what I'm doing. My third stream is going to do a lot of merges. It's going to merge data between the station, and it's going to load it into the eventual table is going to be the station table, right? Those are the 3 tasks which are going to do, which are going to split data from source table into 3. The 4th task is going to actually purge files. So what this is going to do is look at once, and this is the dependent task on top of the push trips task. So when the push trip task completes and the files have been loaded, it will go back and call my procedure, which will go and delete only the files that have successfully been loaded. It will go and delete them from my S3 bucket, right? So that's a good example of a chained task that I spoke about earlier on. Let's grant some privileges so I can execute these tasks, and also I am going to start these tasks. When you create a task, out of the box, it is in a suspended state. It's not running, so you actually have to run a command to resume it. Let's show task command allows me to see the state of my tasks. So I have these 4 tasks have been created. They are scheduled, all of them, the 3 of them have been scheduled to run on a 1-minute interval. And the 4th one, which is the dependent task, does not have a schedule. And as you can see, it has a predecessor column, and it highlights, okay, what is the parent task that this is tied to, right? As you can see the definitions, and if there are any conditions, you can see the conditions. Oh, and one area perhaps I'll probably go back and highlight to you is this condition. So you can see, as part of my task creation, I've said when there is data in this stream table, only then execute the tasks. So if there is no changes happening, these tasks will not be running anymore. That's part of the condition. Let's have quickly now query the tables. I have 21,000 odd or 22,000 odd records that have been loaded into my row. And I have all those changes captured as part of my stream. This is the delta. And soon, now that my tasks have been scheduled, soon they will start to move this data into the modeled and the programs and stations. So let's just refresh them one more time. Yeah, and as you can see now, my stream is empty. All those deltas have been moved. My tasks have done that. They've moved the records into my trips model table, my program table, and my station table. At this point, what I can do is I can bring up Tableau or any other visualization tool to connect with Snowflake and start to visualize this data. Let's just do that. Just take me a minute to spin up my Tableau desktop. I'm going to log into my demo account. This is a direct query mode. So Tableau is going to send queries back to Snowflake, and every time I do something in this dashboard, it's going to do that. So now you can see my dashboard is showing me the total number of trips, which is the same number that we saw back in the Snowflake UI. And I can see some data points along the line. If I go to the number of arrives during the day, and it's, let's just refresh this. And it should be a pretty flat line because I only loaded 1 day of data in there. It's just refreshing itself. Okay, so let's set up a continuous data load. And what I'm going to do is I'm going to use my third script, which is it's going to call my stored procedure, and it's going to drop every 5 seconds. It's going to drop 1 day of file into the S3 bucket. I have my Snowpipe set up, so it will pick all the new files that are landing into S3s. It will automatically ingest it into the raw table. My streams will capture all the new changes, and then tasks which are running on a 1-minute interval will start to put that data into my models table, and eventually I will start to see my Tableau dashboard refreshing with the new data that as it is being loaded. So I've just kicked that pipeline off, and now the files should be written. So if I see my window here, I can see a bunch of copy commands that have been fired, and these are now loading it into the S3 bucket. So let's have a look at the S3 bucket and my stage. You can see I've got second days of files, and I've got 96 files that have been written. Let's quickly have a look at the pipe status. It is starting to process files, right? It's got 32 pending files, 33 pending files that it needs to do. It's done a bunch of them already. I can see what files have been processed, looking at the copy history, and I can see some of the files that are now starting to be processed by Snowpipe automatically. Let's quickly have a look at my table structure and see the counts. I have just over 300,000 rows that's in my row table. However, my modeled table at the moment only has 21,000 odd rows. I've got a lot of data is sitting in my delta, in my scheme object. and the rest of it is pretty much the same. So if I was to refresh this one more time, and now you can see that the data has now moved from my stream, which was capturing the deltas, now into my eventual destination table. It has moved. I can also have complete visibility of the task history and see how my tasks are running. And this will allow me to see if any of those tasks are having any errors. At the moment, my tasks, which are running on a 1-minute interval, are succeeding. There's one which is the purge file task is executing at the moment. So I get to see all the things that are happening behind the scenes, right? This skip status is interesting. That means task, although was, as you remember, I created the task with the condition that only execute when you have data in your stream table. So there were times when I was not generating any data loads, so there was no changes in the streams. Hence, the task didn't really execute. It just went into and skipped that execution. That means I can optimize and I can really do execution when I need to as part of my data pipeline. So the next command allows me to just see, when my pipes are going to be running, and I can see that the next run is in 33 seconds. Let's quickly have a look at more data as it is flowing through. Now I've got 800,000 rows in my row table. My eventual trips table has got around about 600,000 it has captured. The delta is already there. So now we can see that there is a continuous data flow that is coming because my generator is generating the files, loading them into SV, and the rest of the pipeline that I've created is kicking in, and it is loading the data into the destination tables. And as a proof point, I'm going to go over to my Tableau view and refresh this dashboard. And this will start to reflect the number of trips that are actually in my trips table. Just doing that right now. There you go. So now you can see, I see a refresh number in my report, in my dashboard, and that's how you would use continuous data pipelines built using Snowpipe Auto Ingest with streams and tasks on top, and then visualize it as data is loading and arriving into Snowflake. With that, I'm going to stop my load generator, and one final time, I can hop over to the history and actually show you one extra trick, which is if I want to see all the tasks that are being executed, I can use this check flag, which is include queries executed by users tasks. So now I can see that all the queries that are being executed by tasks. What would be interesting is these ones. As you can see, these are remove commands, which was part of my task logic. And a lot of it is a copy command, which I was doing and doing data loading. So I can see exactly all the commands my tasks are executing through the history tab as well. If I go over to the accounts, I can see using and billing information. Snowpipe shows up as an extra cost, and Snowpipe is very granular in terms of its cost. It's the number of files, and it is charged on per core per second basis. So it would really depend on the number of files that the Snowpipe is, or a pipe is pushing and loading, and the amount of time it is running for. So that's an additional charge that shows up. Kafka connector itself does not have any additional charge. However, because Kafka connector underneath the cover does create internal stage and a pipe, so those two objects have a little bit of a charge associated with it. Streams itself don't really hold any more data, so they don't have any charge of their own. But when you create a stream object, it does extend the retention period, like I said, to 14 days. So that means you would have a little bit of an additional storage cost. But then again, in Snowflake, storage is extremely economical. It's $25 per terabyte per month. So really, nobody really worries about the storage cost. We have customers who store petabyte scale data inside Snowflake, and that's not really a concern. with a cloud-native platform like Snowflake. And finally, tasks itself, at the moment, they do run on a compute cluster. So if you saw, I created a task warehouse, and this is a task that all my tasks have been using this warehouse. And so the task compute cluster will have a credit spend associated with it. I imagine this will become a background service just like Snowpipe and replication in the future. But at this point in time, you do need to have a compute cluster that will be executing these tasks. With that, I come to the end of my demo. So just going to hop over back to the slides and just recap what we've done. We used Snowpipe and showed you how to continuously ingest data into your staging tables. And then we created a number of streams and tasks to not only capture the deltas, but also start to transform the data and make it available for visualization purposes. So just to summarize, why would you use, I think we all understand the business benefits of, making data available inside your data platform and being easily consumable by all the users, because there's tremendous value in that. However, having continuous data pipelines, particularly inside Snowflake capability, and having robust pipeline with a lot of monitoring capability built in and a lot of fail-safe capability already baked into that solution is of great value. And Snowflake as a cloud data warehouse, which is highly scalable from a storage and compute perspective and gives you a lot of flexibility in the way the number of users that you can concurrently point to Snowflake, combined with the continuous ingestion into tables, gives you really a strong platform to build your data pipelines and your data warehousing data lake projects. As next steps, as action items, what I would say is perhaps look at one of these use cases. If you're already use Snowflake or are thinking about using Snowflake, is to perhaps look at shredding your, loading your semi-structured data types like JSON or XML raw into a variant column and then shredding it apart into separate columns or separate tables, performing merge and basic transformation using tasks, generating reports and creating aggregates, which will be very useful. Perhaps detecting anomalies inside your data and gathering simple statistics could be a use case. I've seen customers start to think about putting data quality assurances and at times maybe even redacting data as part of a task logic. And also transforming data before you share it with an external party using Snowflake's data sharing capability. You can use tasks and streams to continuously transform data and make and have it in a shape which is shareable to your external organizations. And then last but not least, think about preparing data for ML purposes, because your machine learning algorithms are only as good as the amount of data you have and how accurate that is. With that, I've come to the end of my presentation, and I will open it up to your questions. Quickly going to hop over to I'm going to go through, thank you for your contributions and the questions. I'm going to quickly go through some of the questions I've received in the chat. Do you have any handouts for the session? Could you please share the link to download the slides? Yes, this webinar is going to be recorded and the slides will be made available later on. So that's something that you will be able to have. I have another question. So another question is, why email notification trigger is not added with tasks? How can we alert it? I believe that's already been answered. A question additional question is, for varying volumes for the same stream, what is the best way to auto-scale a task warehouse to maintain a demanding SLA? Well, so again, within the tasks, you can use the alter warehouse command, so change the size of the warehouse on the fly. However, like I said, I expect this limitation to be removed in the future releases and in a very near future, where you will not be required to have a warehouse for a task to be run. It will just run automatically in the background like it does for Snowpipe or for replication. But it is very much possible that you can, as part of your transformation logic, you put an alter warehouse command and change the size of the warehouse before that gets executed. Is it possible to share the demo script? Absolutely. This is something that which is very much shareable, and I will. In fact, there is a video on our website which kind of goes through the same number of steps. I would also point you to Snowflake documentation. Inside the docs, you have pretty much all these commands that I use as part of the demo are mentioned in the doc. So have a look at our streams and tasks section, and also have a look at the Snowpipe auto ingest section to how to set this up. Another question that has come through is, can Snowflake pipeline be configured to send into any application such as Adobe Tools or other applications? My understanding of this capability at this stage is that it is very much a Snowflake-focused capability. It does not really deliver what a lot of the other, I would say, generic data pipeline solutions like Airflow or Oozie do, which can plug into any other solution. At the moment, Snowflake pipelines are very much Snowflake specific, and we are in no way trying to replace what's already out there in the market. This is the idea behind pipeline, is to allow our customers to do in-database processing and basically use the capability from the platform itself. Okay, so the next question is, what error handling exists when a task failed, say, due to a change in upstream schemas? So tasks have, as you can see, that the task has a complete history. So I can see when it is failing and why it is failing as part of that. However, the error handling, I agree, it needs to be improved in the future releases, and that's what the engineering team has told me is something that we're working on. But at the moment, you can see the schedule of the task, the history, when it's going to run next, if there are any errors, and then go about handling those errors. That's what I would say. Okay, another request for the demo script, and the recording has come through. Yep, like I said, these will be made available, and everybody that has registered for the webinar will get a link to the recording. So I also, while we have a few more minutes, I just wanted to also absolutely make it clear that with this new capability, we are not trying to compete with our existing data integration partners, because if you notice, we are doing the T and the L part of ETL. We're not really doing extraction. So although this is very valuable capabilities, but I want everybody to understand that there is still a space for the ETL data integration partners that we very much collaborate with, and that is Snowflake's vision. The primary reason of bringing this capability into Snowflake was because a lot of the times customers who are coming from other data warehousing platforms were using some native capability of those platforms, and they felt that Snowflake was not giving them a choice in this area. And so we've gone ahead and we created Snowpipe Auto Ingest, streams and tasks to capture the deltas and allow you to transform it all within Snowflake if that's what you want to do. Okay, we have a few more minutes left, so I'm open to any further questions. We've addressed all the questions at the moment. I hope you found it useful. If you want to know more, there is a lot of information available on our website. This is a brand new capability. It is in private preview. It's actually in public preview, so anybody and everybody can go and play around with it. You do not need any configuration changes to be made to your existing Snowflake account. So you can today go and create stream objects, you can create tasks, you can create Snowpipe Auto Ingest, and you can, if you're using Kafka, you can certainly take the Kafka from GitHub, put it into your Kafka Connect cluster, configure it, assign topics to it, and it will start doing that data ingestion into your destination tables and into your Snowflake account. With that, I'm going to keep the line open for the next couple of minutes to see if there are any further questions. I want to, again, thank you for your contribution. This has been very interactive, and if you would like to set up any follow-up sessions, please let us know. And myself and my team will be happy to come in and do a deeper dive into any of these capabilities. I only had an hour today, so it had to be kept to a pretty high level. But if you'd like to have a deeper conversation, then please let us know, and we can set up a follow-up conversation as well.